Okay, on number 1, I have sketched what this would look like in step 4. And as I was sketching, I noticed that it's basically a square here, a 4 by 4 square, except I've taken this last corner square and put it up over here. And so on step 15, it would look like this, 15 by 15 square, but I would take this square here and put it up in the corner. And so number 2, how many small squares will there be in each of these steps? In step 4, there's 16 squares, and in step 15, there would be 225 squares. My equation in number 3 is y equals n squared. Y would be the total number of squares, n is my step number. And I figured out that it's just n squared, again, because this is just a square with side lengths of n, and I've just taken this last square and put it up in the corner. Correct answer number 2 is B, and that's because we've taken our square, which is n squared, but we're always subtracting off one square right there. For figure A, the entire square, if they have a side length of x, the whole square has an area of x squared, but then I've subtracted off each corner that has a area of 1. There's 4 of those, so my equation there, or my expression, would be x squared minus 4. That's the area of the blue part. On figure B, again, if each side is x, that means the area of this part is x squared. I have another one of those, and then the area of these small squares, 2 times 2 is 4, so each of those is 4. So my expression would be 2x squared, because I have 2 of those, plus 8. That's the area of those 2 squares on the end. On number 4, I filled in the table and graphed it. Now, number 2 is asking, is the relationship between the first number and the product exponential? So looking at the graph, is this an exponential relationship? It kind of looks like what we saw in Unit 5 with exponential functions. But remember, for those, we need a common growth factor. So let's check our growth factor. To get from 6 to 14, I would need to multiply by 2 1/3. To get from 14 to 24, now I'm multiplying by approximately 1.71, that's rounding. To get from 24 to 50, I'm multiplying by approximately 2.08, and to get from 50 to 84, I'm multiplying by 1.68 exactly. Since that growth factor, or that factor between those, is not the same, there is no common growth factor, and so no, this is not an exponential relationship.